In Unit 5, we're going to focus on the law of sines and cosines so that we can solve for triangles. And the first part of the section that we're going to talk about in 5.1 is the law of sines. Fortunately for you guys this year, we are not going to require the proof, so I will give you the law of sines as is. In any triangle, okay, you would have the sine of angle A over the side A is equal to the sine of angle B over side B, which will be equal to the sine of angle C over side C. And what you need to make note of here is that you will not use all three. You will only use two. Okay? So you will only need two of these. So you might have angle A, side A, and angle C, and you want to find side C. But remember, we're going to talk about all the rules that go with this, but you need to commit these to memory, and they are part of the concept cards. So skipping this whole proof, we're going to go down here. Okay, so what we have is the definition of an oblique triangle, and this is what we're using the law of sines to solve for. So an oblique triangle is a triangle that is not a right triangle. It is either an acute or obtuse triangle. So remember, an acute triangle is all angles are between 0 and 90. Okay, and obtuse, exactly one angle that is between 90 and 180. Okay, so this is all from geometry, so it's really important that you remember these. So to use the law of sines to solve an oblique triangle, you need to know the following. So first of all, you may have a situation where you have two angles and one non-included side. Non-included. So it could be angle, angle, side, or side, angle, angle. Okay, and I'm going to show you a triangle here that you might have. So if you have this triangle like this is angle A, B, and C. Okay, and let's say that you have this angle, and this angle, and this side. So this would actually be side A. So you notice this is a non-included side, meaning included would be between those two. Okay, so you either have this scenario, or you could have angle, side, angle, which means we would have two angles and one included side. All right, so then again, we have our triangle here. Okay, A, B, C. We have angle A, we have angle B, and then we would have this, because it's included, it's between the two, which would be side C. Okay, so we have what's called an ambiguous case, and these two right here are not ambiguous. Okay, not ambiguous, which means there is only one triangle scenario that would occur here. Now, in this third scenario, which is side-side angle, okay, we have two sides and one non-included angle. Okay, so you might have a scenario like this. And so angle A, B, C, and then here this or this. And then you would have the scenario of either angle A or angle C, which would be the non-included angle. Okay, so it could be this angle or it could be this angle. And this right here, side-side angle, is known as the ambiguous case, meaning it's not clear. Okay, and there are three possibilities, meaning you could have one triangle where you would solve for the sides and the angles, and that's the only triangle where that would happen. You could have two separate triangles where this could occur, or you could have none. And we'll go through all three of those scenarios. Okay, so So that's the first part.